Moving into Chapter 7, we're going to begin to meet uh, what I think is one of the most important goals of statistics, and that is using information from a sample to make an assertion about a population. So in this video, we're just going to go through some terminology, and then we'll expand upon this terminology throughout the other Chapter 7 videos. We've already discussed the terms population and samples back in our first couple of chapters. We want to refine this a little bit further by saying that a population is all members of a group. We've seen that before. But a census is a survey in which all members of a population participate. And if you can conduct a census, a value derived from those results, from the population's results, a mean, a proportion, a standard deviation, that is known as a parameter. Now, censuses are very difficult to conduct. It's hard to talk to every single person in the population. For example, if I wanted to speak to every student who attends TCC, that would be very difficult. We have about 10,000 students, and we have students who are on campus a variety of times. We have students who take morning classes, afternoon classes, evening classes, weekend classes. We have students who are full-time, who are part-time, and students who take online classes. So it would be difficult to get in touch with every single student in a reasonable amount of time. Therefore, we can use samples and statistics to make some assertions about the population. Samples are just portions of the members or objects of a group. It's not everybody, but it's just some of the group. And a value derived from a sample's results, mean, proportion, standard deviation, that is known as a statistic. Statistics come from samples. Parameters come from populations. Note that this is a statistics course, so we're going to rely upon samples. Be aware that in your homework, a statistic can be known as an estimator. When you're asked to find the estimator, that's just your statistic, your mean, your proportion, your standard deviation from the sample. And the actual result is known as the estimate. Now, this process of drawing conclusions about the population on the basis of a sample, just a small set of the population, that is known as statistical inference. And inference always involves some uncertainty. We're never 100% sure that we've made the correct assertion about the population because we didn't talk to every member in the population. So there is room for error, and we'll see how we can take that into account in a future video. So typically, we say the population and its resulting parameter are unknown. It's very difficult to talk to everyone in a population unless it's a very small population of 30 to 50 or 100 people. So what we can know about is information from a sample and those resulting statistics. Now there's some notation to be aware of for parameters and statistics. When you're discussing the mean, if it's a parameter, if it's a population, you use the Greek letter mu like we saw back in chapter 6. If the mean is a statistic, if it's from a sample, we use the X bar like we saw back in chapter 3. For standard deviation, we use the Greek letter sigma as a parameter, and we use lowercase s when it's a statistic. And finally, proportions, which are your percentages as decimals, you can think about them that way. If it's from a population, we use lowercase p for that parameter. And if it's from a sample, we use p hat for that statistic. So plain p is your population proportion, it's a parameter. P hat is your sample proportion. In these next several videos, we're going to begin to learn how to use p hat to infer about p.